So we've talked about forces, we talked about electrical charges, we talked about the electric fields that the electrical charges produce. So now we can put them all together. The equation down here shows you the force on a charge, this is charge Q, in an electric field that Q happens to feel. In other words, the electric field at charge Q. Now the electric field at charge Q has to be produced by other charges. So implicit in this equation here is that any group of charges can be divided into two parts for our purposes of calculating forces. One set of charges produce some sort of electric field at the locations of the other sets of charges, and the other sets of charges feel forces. So just to give some example, this picture here shows an electric field. Right now the electric field is 0 in this region, and then we can add particles to it. For instance, if I add a negatively charged particle, so right now we're set at x, charge equals -1 and mass equals 1. So if I add a particle, I will have added a particle of charge -1. So there was no field. I put a negatively charged particle in there, and what happens? Well, we see an electric field due to that charge. Well, so far there's only one charge, so all we have is Q. If we want to put a force on Q, we need an electric field due to other charges. And I can do that by inserting an external field. How about let's put an electric field, external electric field, that's downward. So I'm going to put that in first. Electric field points downward from the outside. Now you can probably guess that the electric field points downward, and up here at the top are a bunch of positive charges because the electric field points away from positive charge. And down at the bottom are a bunch of negative charges, so the electric field points toward the negative charges, and we end up with an electric field that just points straight downward everywhere in between. Let's add a positive charge. If the electric field points downward, so if the E field is a vector pointing down, wherever the charge comes in, the electric field is the same. It's downward everywhere. I put a charge in there if that's a positive charge. This says it's going to be a positive charge. I put a positive charge in. Then I calculate positive Q times an electric field pointing down. Gives me a force pointing down. So let's add that in. And what happens? Well, the ball or the charge bounces up and down, hits the wall and bounces off. The reason it's like a ball bouncing is that there's a constant downward force because the electric field is constant, the charge is constant. There's a constant downward force on this charged object. Add a positive charge again. The picture shows not just the external field. The external field is the field due to other charges, is the field that the particle, the positively charged particle, feels. But the picture here doesn't just show the external field, it shows the whole field. The particle has its own field that points away from it, and so that adds to the external field that points down as the particle moves around. When you're near the particle, fields are basically pointing away from it. There's an external field pointed straight down at that particle right now because it's an external field pointing straight down everywhere. So when I let go, it again bounces. What about a negative charge? I added a negative charge. You look at this formula, the electric field points straight down. Charge Q is negative. If I multiply a negative number times a vector pointing straight down, I get a vector pointing straight up. So in a downward electric field, a negative charge has a force on it that's straight up. So it's an upward constant force. So it's like the bouncing ball turned upside down. Of course, we can add in other particles. Go back and make a positively charged particle and make it really heavy and put that in. And now I have a positive and a negative charge. The negative charge is constantly being pulled upward. Positive charge is constantly being pulled downward. on the other hand, these two charges are going to attract each other. I think I can grab one of them and show you that they stick together.